So, good evening, and let me just present my screen first. So, it is visible to you, right? Yeah. Okay. Okay. So, this is week 5 of probability and statistics, and I'm Kamna Mishra from IIT Mandi, and this course is taken by Professor Sumesh Kumar from IIT Kharagpur. So, today we will basically work on what is normal distribution. Okay. So I think this is the most common as well as most important distribution, most important continuous distribution you will go through. Uh, uh, I think when you will go through your course, this will be the most important one because it has the properties which helps us in finding. And maybe in using the questions and all in solving the questions. So basically, it is a bell-shaped distribution. Okay, something like this. So this must be. So it has property that this is symmetric, and the other thing is that it is bell-shaped, as I have mentioned. So symmetric means if you just draw a line in between, then this portion and this portion will have the same area. So if any point you want to find this region, then it will be equal to this region. Okay. So this and this means the distribution we have here is symmetric. So now if you go through this uh, distribution, like let x follows normal, mu and sigma square, where mu is the mean of this distribution and the sigma square is the variance, and n we have written as normal distribution. So then it's fx x, which is PDF, which is this is 1 upon sigma root 2 pi e to the power minus x minus pi sigma whole square, and this is multiplied by 1 point. So basically what happens is that if you go through this formula, then you will find that finding this capital Fx, capital Fx is what? It is uh, minus infinity to infinity, or where whatsoever is the range of x. If we want to find this, this x up to x, so minus infinity to infinity x 1 upon sigma root 2 pi e to the power minus x minus mu upon sigma whole square 1 upon 2 dx, then it's not very simple to solve this. What do we have is that fx is equal to phi z. We try to find uh, something which is in standard form. So like x follows normal mu comma sigma square. Z we try to find n 0 1. What it means is that we are just converting. Like what you have is sometimes you have x follows a function this and then y is 2x plus 3. So y is just a conversion of x. So sometimes we do this kind of conversion just to make the distribution simple. And this is known as standard normal variant. So now why we use this? So okay. So, do you have any idea what this table is? Or have you ever seen this before? Z table? Okay. So, what do we do here is that so now what is the need of this standard normal variable? So if we have z which follows n 0 comma 1, then fz uh, will be equal to, here we have x minus mu by sigma 2 and all. So okay, let me first tell you how do we do conversions. Okay, so if you have fx, if you have fy, okay, let's say you have two function and one function we can write in a way of second function. So let's just say it fx is uh, x and y we know here is 2x plus 3. Okay, now I'm defining this function as 2x plus 3. Now if we want to find fy, so what is fy if you want to find? Let's say x is from minus infinity to infinity. Then the way to find it is fx is equal to uh, d by dx fy. Now it's if you want to just remember how do we do this conversion, it's just better that remember one variable one side. So fx dx will be equal to fy dy. Okay. So now we have fx, it is x, and dy by dx. So this we can find from here. So it is now we want to find fy. So write everything in form of y. So rather than fx is equal to x, write x in terms of y. So what it will be? It will be y minus 3 divided by 2 is equal to x. So we can write y minus 3 divided by 2. Okay. And dy by dx will be what? Dy by dx will be 2, because 2x plus 3, if you do the differentiation, then 2x will be 2, and for 3 3 is a constant, so its differentiation will be 0. So it will be 2 and fy. So fy you will have will be y minus 3 divided by 4. So this is the way to do conversion. Now we want to find the fz from fx. Okay. So what is z firstly? We want z from n01 and we have x from n mu over sigma square. Okay. Now mu is mean of x. Okay. So what we do is that we take this as x minus mu upon sigma. Now what happens is that expectation of z will be what? Expectation of x minus mu divided by sigma. Okay. Now sigma is a constant term. It will come out. It will be 1 minus sigma expectation of x minus mu. So it will be 1 minus sigma expectation of x minus expectation of mu. Now, mu is again a constant term. So, what is an average of a constant term? Like if you have just 2 as a number, then its average will also be 2 because this is one number. So, just 2 by 1. If you take average of two numbers like 2 plus 3, then it will be 2 plus 3 divided by 2. So, it's just one number's expectation of mu. This is mu is constant, then it will be just mu. And expectation of x. What is x here? X is a normal random variable whose mean is mu. So it is given it is mu. So expectation of x will be mu. So it will be 1 upon sigma mu minus mu. It will be 0. So expectation of z is 0. So this is what we have 0. Now we want to find the variance. So variance of z will be variance of x minus mu upon sigma. Now, for the variance, there is different situation. If you have variance of ax plus b, then its variance is a square variance of x. And for variance of b, it is constant 0. Why is that? If you have just one number, then its variance, that means uh, the range where it vary, it will be 0 because it is a constant, it is just one number. Okay, so that will be 0, and for a it is a square. So a square variance of x. So what it will be? It will be 1 upon sigma square variance of x, and for mu by sigma it will be 0. So 1 upon sigma square and variance of x we have seen here it is sigma square. So it will be sigma square. So it will be 1. So here it is written that it is 1. So Z follows N 0 1. Now Z is standard normal variable. Now we want to find this sorry, this probability density function. So we have Z here, x minus mu upon sigma. Okay. So dz by dx will be what? Dz by dx will be, see, this is constant, this is the only term. So you can just write as z is equal to x by sigma minus mu by sigma. So what will be dz? You know the differentiation, right? Basic differentiation. So you can answer this. Okay. So it will be, this is just constant. So variable times constant, x times constant will be just 1 by sigma. So it will be 1 by sigma. So, in place of this, you will write z. So, it will be minus z square upon 2. 1 by sigma will be cancelled out because of dz dx. So, fz we will have at the end will be equal to 1 upon under root 2 by e to the power minus z square upon. So, this is now standard normal variant. Now, what is the use of it? What do we do is that we have a z table. So if we want to find the probability like z less than 2, what do we do is that we just go to this table, uh, and this is called z table. So firstly you need to understand how we read this table, okay? How to read this table, and then you will be able to solve the questions which I will tell you for this class. So Uh, okay. So now I have told you already this is bell-shaped curve. Okay, something like this. This is symmetric, and this is mean. Okay, mu, which is equal to 0 because now we are taking standard normal variable. Okay. Now it has this property that its mean, median, mode all are same for for normal random variable. So if its mean is mu, then its median, its mode all will be mu. Now the second property I've said that mm, it's symmetric. So symmetric means area before this and after this mean it will be same. Now the total area when this z is standard normal variate when we take this, then its total area is 1. So what do we have here is that the area covered until this is point 0.5. Okay. So zero point 0.5, and then if we have something like after this, then it will have zero point 0.5 plus this area. Now, if you have a point here, and if you have a point here, then it if this is 0, then it will always be in minus 1. Okay. So if we want to find phi of minus 1, phi of minus 1 will be what? Phi of minus 1 will be this area. Okay, this area. So now this area is equal to this area, right? So if you have just table for the positive, what you will do is that you will subtract 1. This will is phi 1. This is phi minus 1. So to find this area, this is equal to this one. So what do we do here is that we take 1 and then we subtract 1 minus 5. So if you take 1 and you subtract this area, this is phi 1, you will left with this portion. So this is equal to 1 minus phi 1. So this is the basic formula that phi minus z is equal this is equal to 1 minus pi z. So this we will use for this several times because uh, we need to this is not always that you will have this table like negative 1. It may also happen that you have the table for negative 1 and not for the positive 1, then you may deal with this. What's the second thing? uh, it may happen that you have this table like from point 0.5. Okay, so when it is 0 it is point 0.5. It may also happen that you have the table where it will start from 0. It's okay. No, but it may happen that it is starting from 0, so then you need to add. So when we will do question, I hope you will understand it how what I'm saying and what how it is making some sense. Okay. So now this is the first question. What is given here is that IQ level of candidates for a particular job selection are normally distributed with mean 90 and standard deviation 5. Then we want to find the approximate probability that a randomly selected candidate has an IQ between 85 to 90. So what is given here is that it is 90, standard deviation is 5. So it is not given in the standard form. What do we do here is that we will firstly convert it into the standard form. So given here is that x follows normal 90 and mu is comma sigma square. So it will be 5 square. Okay. So now we need to find the probability that x is in between 85 to 90. Now what do we do here is that we will convert this x into standard normal variate. Now standard normal variate will be z is equal to x minus mu upon sigma. So x minus mu upon sigma, what do we have here is that we will do this for every portion or whatsoever you say, every value. So it will be probability of 85 minus 90 divided by sigma, it is 5. Uh, it will be x minus 90 divided by 5, and it will be less than 95 minus 90 divided by 5. So this will be equal to probability that will be minus 1. It will be now z, and it will be 1. So have you understood up to this? Like till now, is it making sense? So now what we need here is that we have this p is from minus 1, z is from minus 1 to 1. So how do we calculate any probability like this? We Let me just write it here. If you have any p from a, x, b, it will be equal to p f of b minus f of a. Because if you see it from the plot, and let's say we have curve like this, okay, and this is a, this is b. So probability of a, x is in between a to b is basically the area which is in between a to b. Okay, so this is, this we want to find. So what is fb? Fb is this, and if you cut this portion, which is FA. So this one is FB, this one is FA. So we will be left with probability in between A, X, B. So we will write it like, so we will write it as F of 1 minus F of minus 1. Now this in the time of standard normal variate, we represent this as phi, capital phi. So capital phi is this. Now what I have said earlier is that phi of minus z is 1 minus phi z. So it will be phi 1 minus 1 minus phi 1. So this will be positive. So ultimately you will have 2 times phi 1 minus 1. Now we want to find phi 1. Phi 1 means z at 1. So this is how you will see the table. So this is the z table. You can get it from anywhere. All you need to remember is that, like, sorry, this is like i- whether it is starting from the point 0.5 or whether it is starting from 0, that you need to understand. If it is starting from point 0.5, it's okay, nothing, because at 0 mean 0, it should be point 0.5. But sometimes what they say is that they start this table from 0, so then you need to add this point 0.5. Okay, so this is from point 0.5. Now you need to you need the value at phi 1. So z at 1, this is 1. Okay, so this will be the value. If you have 1.3, then it will be 1 and then point 0.3. So 1.3 will be this. So now this will be the value 0.8643. Is it visible to you? what I'm saying? Okay. So it will be 0.8413. So now we have 2 times. So it will be answer will be 2 times 0.8413 minus 1. Now you can calculate it. 2 times 0.8413 minus 1. It will be 0.6826. Okay. So this will be the answer. So now move to next question, and this is similar to the previous one, and also it will use the property which I have told you earlier. Like in this question, what is given here is that suppose four candidates are randomly selected. So X is still following this same normal. X is still the same normal random variable, which has mean 90 and standard deviation 5. Now, what we are doing is that we are conducting a survey or whatsoever, and we are selecting these four candidates randomly. And now we want to find the probability that at least two of them have IQ levels between 85 to 95. So here we have found that the probability that IQ is in between 85 to 95 is 0.6826. So we have 1, 2, 3, 4, and we want to see that at least two. Now, at least two means we can either do that two that probability that two candidates have IQ in between 85 and 95, three have them, and then four have them. So we can do it by two types, like two ways or type, whatsoever you want to say. So if you can do at least uh, two out of four have IQ between 85 to 90. Okay. So you can do it in two ways. Like one way is that you can just say that probability that two have this property, and then probability that three have, and then probability that four have this IQ. Okay. Or what you can do is that 1 minus probability that no candidate have this property, and then probability that one candidate will have this property. So if you will apply this also, then it means 1 minus you are just removing the times when uh, less than 2 have IQ levels between 85 to 95. So either way you solve this problem, the answer will be the same. So I'm going to solve it by the second way, because this is the most usual way, because you may have like at least one, then it will be 1, 2, 3, 4. It can be, you can just choose whatsoever is simple or less calculative. So here I need to just calculate for 2, and here I need to calculate for 3. So I'm gonna use this. Now probability that no candidate have IQ between 85 to 95. We have already found the probability then when candidate have IQ in between 85 to 95, which is 0.682. So now that probability that it does not have IQ in between, does not have IQ between 85 to 95 will be what? 1 minus 0.682. So this will be 0.318, right? So now we have 1 minus probability that no candidate have IQ in between 85 to 95 minus 1 candidate have IQ in between. So it will be 1 minus no candidate, and we have 4 candidates. That means all 4 have IQ levels not between 85 to 95. So what it will be? It will be 0.318 to the power 4. Okay. And here it may happen that first candidate have IQ in between 85 to 95 and other three not have, and it may happen that second person, third person, fourth, because they are not identical, they all are different person. So what do we do is that we choose one person out of them, so it will be 4C1. So out of 4 any candidate have this property, and its IQ will be in between 85 to 95 and others does not have. So for others it will be true. So now you can solve it, and the answer it will be 0.90. So 902 or whatever, because we have not taken everything here. So this will be the answer. Is it okay? So now the next question we have here is that x is following normal distribution 12 comma 0.01, and y is 220x plus 3. Then we want to find the probability that y is in between 239 to 241. So how do we solve this? We have x which follows normal distribution 12 comma 0.0. Okay. And y is what? 20x plus 3. Now we want to find what is the distribution y is following. So if x is following normal distribution and y is some linear form, like linear way or linear equation it is representing, then y will also uh, go through, and y will also follow this normal distribution. So y, and now we want to find what are the mean and what are the variance of it. So y is 20x plus 3. I have told you earlier. What is the expectation of y? It will be expectation of 20x plus 3. So it will be 20 expectation of x plus expectation of 3. Now 3 is constant, so expectation of 3 will be 3, and expectation of x we have here is that 12. So it will be 20 times 12 plus 3. So it will be 243. 243 will be mean of y. Now variance, this is the variance. So for variance of y will be variance of 20x plus 3. Now it will be 20 variance of x plus variance of 3. Now 3 is a constant, so its variance will be 0, and variance of x we have here is that 0.01. So it will be 20 times 0.0. So it will be, sorry, 20 square. So for the variance it is a square variance. So it will be 20 a square is 0.01. It will be 400 times 0.01. It will be 4. Okay, so variance of y we know now it is 4. So what y follows? Y follows normal distribution 243, comma 4. Okay. Now, now we need to find the probability that y is in between 239 to 241. So now this is similar to the question we have done here. Okay. So this is probability 85 to 95. Then what we do is that we just subtract this by minus by mean and then divide by 0. Okay. So it will be probability that 239 by 1 will be equal to probability. Now it is 243 before. So it will be 239 minus 243 divided by 2, because this is the variance, so sigma square is the variance, sigma will be 2. It will be y minus 243 divided by 2, and it will be less than 241 minus 243 divided by 2. So ultimately we will have probability, this will be minus 4 by 2, so it will be minus 2. This will be z, and this will be uh, minus 1. So it is in between minus 2 to minus 1. So what we can do here is that you can just directly see that it is minus 2 to minus 1 will be same as 1 to 2, or either you can write it as phi of minus 1 minus phi of minus 2, and then for this you can write 1 minus phi of minus 1 minus phi of 1 minus 1 minus phi of 2. Okay, so 1 and 1 will be cancel out, it will be phi 2, this minus minus will be 1, so it will be phi 2 minus phi 1. So ultimately you will have phi 2 minus phi 1. That means we need the value of z at 2 and 1. So now we will go through the table. So this is phi 2 is 0.9772. So it is 0.9772 minus phi of 1 is 0.8413. 0.8413. Now you can subtract it. So 0.9772 minus 0.8413, and this will be 0.1359. Okay. So 0.1359 will be the answer. If you have any doubts, you can just ask, like in between us. I'm audible to you, right? So next is that it is noted that 5% of the pages on a corporate website contains error. If 100 pages are checked randomly, what is the probability that at least one of the checked pages have error? So now this is what you can see is that X is 100 pages. Uh, so it is 100 pages, and probability that it has some error, it will be 0.5. So basically it is following binomial. Okay. What you can do is that you can just use the binomial probability that x greater than or equal to 1, that at least one of the checked pages have error, then it will be 1 minus probability of x is equal to 0, which will be 1 minus, uh, it will be 100 c 0 and then 0.05 to the power 0 and 0.95 to the power 100. Now, this is very difficult to solve, like 0.95 to the power 100. It's not easy to solve this. So, what we do in this kind of question, we approximate it. Okay. So, how do we approximate it? Like we can approximate it either to Poisson or we can do it for normal. Okay. So, for normal, how do we do that? This is the question. So this is binomial. This is n. This is so. Now what we know here is that mean mu is np for binomial and sigma is npq. So mu is np, which will be np 20, and uh, sigma square is npq. So it will be 100 into 0.05 into 0.9 into 0.5 into 0.9. So it is 4.7. So now you can do that. X follows normal with 20 and 4.75, and then you can do like probability x greater than or equal to 1. So x is equal to 0. It means x have no error. So it will be less than 0. Other way you can solve it is that you can do the Poisson approximation. Now for the Poisson approximation is the easiest way I think here. This is NP. NP is lambda for Poisson approximation. This is lambda p. So x follow Poisson, okay, and lambda is just 20. So px greater than 1 will be equal to 1 minus px is equal to 0. Now, if you may remember what is the Poisson distribution, it is fx is equal to e to the power minus lambda, lambda to the power x divided by x factorial. Okay, so here x is 0, x factorial is 0, e to the power minus lambda is all we have left. So it will be e to the power minus, it will be 100 times, so 100 times 0.05 will be 5. So lambda will be 5. So it will be e to the power minus 5. Now rather than calculating 0.95 to the power 100, which may you maybe I think you will get the error. So you can solve this. Now e to the power minus 5, you can just solve it in the calculator, and then you will have the answer as 0.9936. So which will be similar to this. So it will not be the exact answer if you do any kind of approximation, like if you go from binomial to Poisson or if you go from binomial to normal. The answer will not be exact, but it will be almost similar. Okay, so this is you can do, like if you are unable to solve this kind of question, because Up to n is 30, we do the binomial, and if n is greater than 30, then we go for any other distribution. Now, next question. That was clear, right? So now next question we have here is that suppose x be a standard normal variable and find x is less than 0. This is what we need to find. So probability x less than 0 given that greatest integer x is equal to 1. So now firstly we will see what is this. So uh, do you know what is greatest integer x? Okay. So uh, do you know what is mod x? Okay, so mod x is the function uh, which breaks where it changes the sign. Okay, so now this will change the sign. So what we say here is that if we have mod y is equal to some a, then y will be either a or minus a. So basically taking the modulus value, absolute value, these all are things are same. So if we have a mod of greatest integer x, it means that greatest integer x is 1 or minus. Now question is that when will the greatest integer is 1 and when will it will be minus 1. So greatest integer function works like this. This 0, 1, minus 1. This, this, this. Basically, it is the step function. So step function, what is that? It means if you have x is in between 0 to 1. Okay, x is any real number which is in between 0 to 1, something like this. Okay, but not 1. It can be 0 but not 1. Then greatest integer x will be 0. So, what do you mean by greatest integer? It means if you have any real number, what is the greatest integer which is closer to that value? Okay. So, greatest integer x means the integer which is closest to that real value. Okay, and it should be less than that, not greater. So, if it is in between 0 to x1, then greatest integer x will be 0. Let's say it is in between minus 2 to minus 1. Okay. And you have x as minus 1.5. So now you know that minus 1 is greater than minus 1.5. Okay. Right? In negative, it works in opposite way. So minus 1 is greater than minus 1.5 and minus 2 is less than minus 1.5. So then its greatest integer will be minus 2. So now when it will be 1, when 1 to up to x2. So when x is in between 1 to 2 but not 2, its greatest integer would be 1. Now for minus 1, it will be when minus 2 to x. No, sorry. It will be from minus 1 to x 0. When x will be 0, greatest integer will be 0. Up to minus 1 to 0, greatest integer will be minus 1. Okay. So now this is the thing we have. So if we have x is in between this and x is in between this, then greatest integer x will be 1. So now we need the know the probability of the denominator. Okay. Next, what we have is that x is less than 0 given greatest integer x is equal to 1. Now, if greatest integer x is equal to 1, it means x is in between 1 to 2. So x cannot be 0 at that point of time. So x cannot be 0. But when x is between minus 1 to 0, that's the point when x is less than 0. So it just take it as an intersection, which it is. So x less than 0 intersection this. So below we will have probability of this. Just add one more slide. So probability that x less than 0 divided by mod of greatest integer x is equal to 1 will be equal to probability that x less than 0 intersection this is equal to 1 divided by uh, divided by probability of this is equal to 1. Okay. So now this means x is in between minus 1 to 0, and below we have probability that is in between minus 1 to 0 plus x is in between 1 to 2. Now when x is in between minus 1 to 0, it means that phi of 0 minus phi of minus 1. Okay. So this will be minus 1 to 0, it will be phi of 0 minus phi of minus 1. This will be phi of 0 minus phi of minus 1 plus phi of 2 minus phi of 1. Right? Now phi of 0 is zero point 0.5 because it is the mean value. Okay, and phi of minus 1 will be what? 1 minus phi of 1. So it will be zero point 0.5 minus, it will be 1 minus phi of 1. The below we will have phi of 0 as zero point 0.5 minus phi of minus 1 will be again 1 minus phi of 1. Then it will be phi of 2 minus phi of 1. So this is minus, and if you just put minus inside, then it will be plus. So this will cancel out. In the above, we will have zero point 0.5 minus 1 will be minus zero point 0.5, and this minus minus will be plus. So it will be phi of 1 minus 0 0.5 divided by, sorry, and this will again be zero point 0.5 minus 1 will be minus zero point 0.5, and this will be 5. So it will be phi of 1 minus zero point 0.5 divided by phi of 2 minus zero point 0.5. So this will be the answer. Is it okay? Okay. So next question we have here is that the study region in Center Phoenix, Arizona recorded 10,500 asthma incidents, and in children in a 21-month period. So we have T is equal to 21. So in 21 months, we have 10,500 incidents of asthma. Now, assuming the number of asthma incidents follow the Poisson distribution, and then we want to find Px greater than or equal to 550. Now, what is given here is that use normal approximation to Poisson distribution. Now, again, what we have is that rather than solving it by Poisson distribution, like we can do it by Poisson also, but we will choose to solve it by normal distribution just to make the calculation easy. So 10,500 in 21 months. Okay, so in 1 month we will have 10,500 divided by 21. So it will be 21 times just 5 will be 500. Now you know when it is Poisson distribution, for Poisson distribution mean and variance is same. So it is lambda and lambda. So x is basically follow. We are taking normal approximation, so x will be normal 500 comma 500. Okay. Now we want to find p x greater than 550. So it will be again x minus 500 divided by under root of 500 greater than or equal to 550 minus 500 divided by root of 550. Okay, so it will be x minus 500 by 550. This one will be z and it will be greater than or equal to 50 divided by, sorry, this is 50 divided by root of 500. So it will be z greater than or equal to 50 divided by root of 500 will be root 5, which is 2.236. Now z greater than 2.236. Okay, z greater than 2.236 will be what? 1 minus 5 at 2.236. So whenever you have confusion like whether we need to do minus or plus or direct value, then always try to make this plot. If you make this plot, these things will be very clear. So for 2.236, what we have here is 5 of 2.236 is the region up to this. So if we subtract it from 1, because 1 is the total area, then we will have this value. So 1 minus 2.236 will be the value. Pi of 2.236. Now we will go to the table. Okay. So 2.23 will be 0.9868. So 0.986. It will be 0.9871 because 3 is here. So it will be 0.9871. So it will be 1 minus 0.987. So now you can see this is the only smaller value. So this will be the answer, or you can solve it just once. Okay. So next question given here is that the time until the recharge of a battery in a laptop computer under the common condition is normally distributed with the mean to 60 minutes and deviation 50 minutes. What is the quartile of battery life? So do you understand what is quartile? Okay, so percentile, right? You say 90 percentile, 95 percentile. So when we say percentile, that means we are dividing like one region in 100 terms. Okay. So let's say you have one region and you're dividing it by 100 times, 100 portions, then it will be 100 percentile. Okay. Now when you divide it by four regions, okay, let's say this, then it will be quartile. So quartile will be Q1, Q2, Q3, and Q. These are the quartiles. And Q2 is median. What we say about median is that up to this, the area is zero point 0.5. Okay. So area is zero point 0.5 means it is dividing the region into second quartile, or into, yeah, if you divide the region into just two parts, the middle one is the median, okay, in basic term. So quartile means we are dividing the region into four parts. So first one is first quartile, second quartile, third quartile, fourth quartile. If you divide it in 100, it will be percentile. So it will be first percentile, second 90 percentile, 95 percentile, and that what we use in significance and all. So this is the use of quartile. So at Q1 it will be 0.25. It will cover 0.25 region. At third quartile it will cover 0.75. That means 75% of the region. And at fourth quartile it will just take uh, the whole region. At fourth quartile it will cover the whole region. Okay. So now we want to find what is the first quartile of the battery life. Means if you have mean is 260 minutes, then what is the first quartile means that it has already covered it 25% of the life. So now we have probability. Uh, Now it is again x greater than or equal to q. Okay. And this is equal to 0.25. That means it has covered the region 25%. Now it is again uh, 260 square, so we will convert it to standard normal variate. So it will be probability x minus or 260 and 50. It will be greater than q, and this is the q we want to find. 260 by 50, it is equal to 0.25. Okay. So now this is just z. This is q minus 260 by 50. This is we want to find. So we have p of z greater than or equal to uh, q minus 260 by 50, and this is equal to 0.25. So now to find like pz greater than or equal to 1 if it is 0.25. Then we want to find what is the z value at this 2.25. Okay. So now we read the table in its reverse form. Okay. So it is greater than 0.25. So it will be 1 minus 1 minus either you can say 1 minus 5 of this q minus 260 by 50, then it will be 1 minus 0.25. So basically we will try to find 1 minus this, and it will be 0.75. Let me just write it firstly. This will be z greater than uh, greater than or equal to q minus 260 by 50 is equal to 0.25 will be 1 minus 5 q minus 260 by 50 is equal to 0.25. So 5 of q minus 260 by 50 will be equal to 0.75. Now we want to find at which value of z it is 0.75. So here you need to point where is 0.75. So it is approximately 0.75717. So this is, you can see it is at 0.68. So it will be 0.68. Okay. So now all you need to do is that write 260 q minus 260 by 50 as 0.68, and then you will find this value of a q. That q will be the answer, and the answer is 2 to 6.28, something like this. So next question is that suppose Z be the standard normal distribution and find. Okay, there is some mistake. What is the first quartile of the battery life will be less than or equal to Q? So sorry for this confusion mistake. So it will be less than. So it will not be this. If you will subtract it, you need to subtract it from both the sides. So ultimately it will be 5 of minus. So don't do this, just do this, and it will be minus of 0.68. So q minus 260 by 50 will not be equal to plus, it will be equal to minus of 0.68. Now you can see. So the next question we have here is that expect. This one was clear or do you have any confusion still? Okay. So next we have find the expectation of minimum of z comma 0. So what we do is that we can just use it as a function, like y will be z when z is greater than 0, and it will be 0 otherwise. Okay. If it is minimum, then it will be 0. So now we want to find this expectation. So what it will be z is standard normal variate. So for standard normal variate, f of z is what? 1 upon root 2 pi e to the power minus z square upon, right? Z square upon 2. Now to find expectation, what we will do is that minus infinity to infinity z upon uh, sorry, up to 0 it will be z, and for 0 to infinity it will be z upon root 2 pi, okay, e to the power minus z square upon 2 dz, and plus When it will be 0 to infinity, it will be 0 divided by whatsoever. So 0 fz dz, which will not make any sense. It will be 0. Yes. So up to minus infinity to 0, this will be the value. Now to solve it, what we will do is that we can take just z square upon 2s, some t, let's say. So let's take z square upon 2st. So 2z by 2 dz will be dt. So z dz we already have. So z dz will be dt, and at minus infinity it will be infinity. At 0 it will be 0. So it will be, we will have infinity to 0, 1 upon root 2 pi e to the power minus t dt. Okay. Now term, this term is constant. It will come out. We will left with e to the power minus t. So it will be 1 upon root 2 pi. And for e to the power minus t, it will be e to the power minus t divided by minus 1. Right? Its integration. It is from infinity to 0. So when we will put 0, it will be e to the power 0, and this will be 0 upon minus 1 will, sorry, e to the power 0 will be 1, so it will be minus 1, and at infinity it will be e to the power minus infinity. So e to the power minus infinity will be what? 1 upon e to the power infinity, and 1 upon e to the power infinity will be 1 upon infinity, which will be 0. So for this term it is 0, for this term it is minus 1. So ultimately we will have minus 1 upon sigma root 2. So this will be the, okay. So next we have here is that the IQ level of a group of a student is assumed to be normally distributed with mean 110 and standard deviation 15. So firstly we will just write x follows normal 110 and standard deviation is 15. So it will be 15 square. Now the probability that a randomly selected student has an IQ of at least 100 plus k. That means x needs to be at least 100 plus k. Okay. Is 0.2033. Okay. So now what we do here is that firstly we will convert it to standard normal variate. Okay. So this is our z, and it 110 will be cancelled out. Will be k by 50, which will be 0.2033. So now it is greater than, so it will, we will write it as 1 minus probability z less than or equal to k by 50, which will be equal to 0.2033. So probability that z less than k by 50, which will be 5 of k by 15, will be 1 minus 2033. So 1 minus 2033 will be 1 minus 0.2033. will be 0.7967. Now we need to find the 0.7967. So this is 79397967. Okay. So 7967 is at 0.83, right? So k by, so now this is pi of 0.83. So k by 15 will be what? It will be 0.83. So k will be 0.83 times 15. 3 times 15, which is equal to 12.45. Now, greatest integer I have told you earlier, it is the integer uh, which is nearest to the real value and it is less than that value. So, if k is 12.45, its greatest integer will be, so this will be the answer. Now, the next question we have here is that the diameter of a dot produced by a printer is normally distributed with a mean diameter of 0.005 centimeter and the standard deviation, of 0.001 centimeter. Now we want to find the probability that diameter is in between 0.0035 up to 0.0065. So this is, I think, very similar to the previous questions what we did. So what is given here is that x follows normal 0.005 and its standard deviation is this. So what is the probability that diameter is in between 0.0035 and 0.006? So I think I have solved enough of questions like this. Can you do this one? Like all you need to do is that probability this x minus mu, and then by sigma. So do it for this and this. Tell me the value what you will get here and here. Is it okay? Can you do this? No response. Okay, I'll just wait for 2 minutes. Otherwise, I'll. हेलो. नहीं नहीं मैं क्लास कर रही हूँ. इस तो मेरे. हाँ, मैं करती हूँ. Are you solving this? So this is 0.0035 minus 0.005 and divided by 0.001. So it will be minus 1.5. I'm writing it directly, you can solve it now. And it will be 1.5. So probability that x is in between minus 1.5 to 1.5 will be 2 times it is 1.5 minus 1, and at 1.5, 1.5 it is 0.9332. So 2 times 0.9332, 332 minus 1 will be equal to 0.866. So this will be the. So the next question we have here is that the lifetime of a semiconductor laser follows log normal distribution with mean 10 and standard deviation 1.5. Okay. So log normal distribution have mean given by expectation of x is equal to, where x is following the log normal distribution, is e to the power mu plus sigma square 2, and its variance of x is given by e to the power sigma square minus times e 2 mu plus sigma square. Okay. So this is we have given as mean 10 and variance is given as 1.5. So what do we do here is that we will solve it for mu and sigma square, and then we will go to the mu and sigma square as a normal variant, and then we will solve it. So if you will solve this and this equation, because it will take so much of time, so I'm just writing the answer, you can do that later. It will be 2.29146, and sigma square we will get it as 2. So now we want to find that probability x is greater than or equal to 15. So it will be um, and this is now log normal. The log normal will be ln of x or ln of 1. So we will take it as z as ln of 15. Okay. So z is greater than ln of 15 minus mu of 2.29 divided by 0.0225. Okay. So now if you will solve it, ln ln 15 minus 2.29, it will be 0.418, and 0.418 divided by 0.0225, it will be, sorry, it should be under, so 0.418. Ultimately when you will solve it, it will be 2.79. So at 2.79 you can check the value. So at 2.7 and 9 is here, it is 0.9974. So this will be what? 1 minus pi of 2.79, which will be 1 minus 0.9974, and that will be 0.002613. So there is this calculation involved which you can do, and if you have any issue in solving this, then I'll say it in the next class. Okay. So next question we have here is that it is of variable distribution. So maybe you remember variable distribution can be given by 1 minus expectation x upon alpha to the power beta. Okay, it's fx can be given by this. So what is given here is that alpha is equal to 1, beta is equal to k. What is the value? Assume that the life of this in this is following Weber distribution. So what is the value of k so that the probability that disk fails before 2 years is 0.708. So probability that disk fails before 2 years. That means x is less than or equal to 2. If we say x is lifetime of disk in years. So if lifetime of a disk we say in years, then it will be probability of x less than or equal to 2, which is given as 0.708. Now x less than or equal to 2 is what? Fx. So it is basically f2. Now f2 will be given as 1 minus e to the power, okay, x is 2, alpha is 1, beta is 3. So 2 to the power minus minus 2 to the power k, and it is equal to 0.708. So e to the power minus 2 to the power k is equal to 1 minus 0.708, which is 0.292. Now you can solve it by taking minus 2 to the power k is equal to ln of 0.292. So ln of 0.292 is minus 1.23. So minus 2 to the power k is minus 1.23. So 2 to the power k is 1.23. And then you need to take ln again. So what we will have from here, it will be uh, k ln 2 will be ln 1.23. So it will be ln 1.23 divided by ln of 2. So when you will solve this, it will be 0.3. Now, next question we will have here is that the time between the arrivals of customer at an ATM machine is exponentially distributed, random variable with mean 10 minutes. And what is the probability that starting at 9, this is 9 a.m., the third customer will arrive within the 15 minutes. So now it is within 15 minutes and it is exponentially distributed. But when we have n as number, what we do here is that we use that there is a relation between exponential and Poisson distribution. So when we have any number of customer arriving at this point of time, we use at that point of time this Poisson distribution. So it is arriving within 15 minutes. Firstly, mean is given as 10 minutes. So in the time of exponential, mean is uh, if x follows exponential lambda, then this lambda is expectation of x is 1 upon lambda. Okay. So lambda given here is 10 minutes, so it will be exponential 1 upon lambda, which will be exponential, exponential 1 upon 10. Okay. So this one is the parameter lambda. So x is following exponential 1 upon 10. Now what it is saying that it arrives within the 15 minutes. Third customer arrives within 15 minutes. So within 15 minutes, what we will say is that uh, we take it as lambda t to the power n e to the power minus lambda t divided by n factorial, where t is time. Okay, lambda we know lambda is parameter, and n is the number of customers or whatsoever is number. So it will be, and you must remember when we time in the time of exponential, what is fx? It is 1 minus e to the power minus lambda x. So it is 1 minus this. So this will be the probability of x which we want to find. Okay. Now it will be 1 minus lambda t will be what? Lambda is 1 upon 10 and t is 15. So it will be 3 by 2 to the power n is 3, 3 factorial, and e to the power minus 3 upon 2. 3 upon 2 will be lambda t will be what? Lambda is 1 upon 10 and time is 15. Okay. So it will be 3 upon 2. So this will be 1 minus 3 upon 2 cube by 3 factorial e to the power minus 3 upon 2. This will be your answer. Okay. So next question we have here is that we have is that uh, the train arrive and depart at Kanpur railway station according to Poisson distribution with a rate 1 per 3 minute. Okay, per 3 minutes. What is the probability that between 2 to 3 p.m. the number of trains arrive or departing is at least 17 or not more than 25? Use the binomial approximation with continuity correction. Okay. So now x is following what? 1 per 3 minutes. So rate is 1 by 3, and for Poisson, uh, mean and variance is same. So it will be 1 upon 3, 1 upon 3. Okay. So between 2 to 3 p.m. So it is the difference of 1 hour. Okay. So for 1 hour, it will be normal, and x follows Poisson. And hydrogen this way, normal. So for 1 hour, it will be just uh, multiply by 60. Okay. So for 1 hour, it will be 20 by 20. Now what is given here is that it is at least a 17 or and not more than 25. So if you will go to Poison, then you need to find it for 17, 18, 19, 20, 21, 22, up to 25. But for the normal, what we do here is that we will use word standard normal variate, and then we will just find it. So it will be 17 minus 20 divided by under root 20. Okay, less than or equal to that will be z, and 25 minus 20 divided by 220. So it will be probability. This one is minus 3 divided by root 20. It is 0.67, and 25 minus 20 divided by root 20 will be 1.118. So now it will be, now we need to find the probability at 1.118 and 0.67. So 1.11, okay, it will be 0.8665, right? 1.11, then 8 is not given here, so it will be 0.8665. It will be 0.8665 plus 0.67. So it will be 0.67 will be 0.7486. This 0.7486 and minus 1, because this one is negative. So that one will be 0.8665 plus 0.7486 minus 1 will be 0.6 something. So it will be around 0.6. So this will be this. So the next question we have here is, this is also after this point you can solve it on your own. I will just tell you how to do this. So what is given here is that z is 1.25, okay. Z is minus 1.25 when x is equal to, when x is equal to 40 and z is 1.98 when x is equal to 60. So basically it is given as z. What is z? Z is x minus mu upon sigma. So you have given two equations, like 40 minus mu upon sigma will be equal to what? It will be minus 1.25. Okay. And then 60 minus mu upon sigma will be 1.98. So you have two equations. 40 minus mu is equal to 1 minus 1.25 sigma. So you have first equation is 40 minus mu is equal to minus 1.25 sigma, and 60 minus mu is equal to 1.98 sigma. Now you don't need to solve this by, like, on your own by using the calculation. You can just solve it using the calculator. If you don't know, you can see the videos for it. So just calculator, go to the mode, and here you will see this fifth one is equation, and then you can select the equation type that it is first one, and you can just put the values. So after solving, like I have solved this earlier, so after solving, what I have got here is that 47.739. and sigma is 6.19. So these are the values of mu and sigma. Now what is given here is that we want to find probability of x minus 40 greater than 10. X minus 40 greater than 10. So when it will be greater than 10, mod x value will be greater than x when x is greater than a, or x is less than minus a. Okay, because mod x dot is like this. So for greater than a, it will be either this way or this way. Okay. So it will be x needs to be greater than minus x minus 40. So you can either do this way or this way, like open it with positive, so it will be x minus 40 greater than 10, so x will be 50, and then it will be minus x minus 40 greater than 10, so it will be minus, let me write it, you can do it as when it will, when it as negative, it will be this greater than 10. Okay. So you can just do 40 minus 10 will be, so it will be x is less than 30. So x is either greater than 50 or x is less than 30. So if you see this plot, okay, so x is uh, greater than some value, less than some value, or greater than some value. That means if we subtract this 1 minus this, then we can get this portion and this portion. So it will be 1 minus probability that x is in between 30 to 50. Now you know the mean value, you have the sigma value, and you can solve it. If, if we will left with the time, we will solve. These all things are making sense, I hope so. So next question we have here is that x is a continuous random variable with the density function given as fxx as 1 by 6, 1 minus mod x by 6 when x is in between minus 6 to 6. And now we want to find the probability that x is less than, or mod x less than 5. So firstly, when we have mod x less than 5, then it means x is in between minus 5 to 5. So for minus 5 to 5, we already know if x is in between minus 6 to 6, it is following this. So for minus 5 to 5, it is 1 by 6, 1 minus mod x by 6 dx. Now this is mod x. So mod x changes its sign at 0. If you have mod x minus 3, then it will change its sign as at 3. So if you have mod x plus 3, then it will change its sign where it is equal to 0. So it will change its sign as at 3, minus 3. Sorry. So since it is mod x, so it will change its sign as 0. So what it will be, So it will be minus 5 to 0, 1 upon 6. It will be 1 plus x upon 6, because when it changes its sign like this. Okay. So x up to 0. So before 0 it is minus x. So before 0 it is minus x. So it will be minus minus plus 6. So it will be this plus 0 to 5, 1 upon 6, 1 minus, and for positive value it is plus. So it will be x upon 6 dx. So now you have 1 by 6. So both have 1 by 6, you can take it common. And here you have 1 plus x upon 6. So for 1, it's 1 dx is x, and x dx will be x square upon 2. So it will be x plus x square, and there was 6, so it will be 12 minus 5 to 0 plus x minus x square by 12. It will be 0 to 5. So it will be 1 upon 6. Uh, you can put it 5 minus 25 upon 12 plus 5 minus 25 upon 12. So it will be 5, 5, 10, 10, 120 minus 50. So it will be 1 upon 6. It will be 10. It will be 120, 50, 50, 25, 25, 50. It will be 70. I think 70 by 12 times 6. So it will be 35 divided by 12 times 3 will be 36. So it will be 35 by 36. So this will be the answer. Next question we have. So we are left with two questions. And this is we will solve in the next question, because you have no idea how to do this maximization. So up to this we will solve. So now this question is that in a probability and statistics class, the total number of students is 200, and a professor gives question to students as a surprise test. Then the probability that a randomly selected student can solve the question. The probability that a randomly selected student can solve the question is zero point 0.5. Then we want to find the probability that at least 110 students in the uh, class cannot solve the question, and use the normal approximation to binomial without continuity corrections. So total number of student is what? And yes, 200. And then the student can solve the question. P is 0.5. Q will be zero point 0.5 also. So mean is given by NP. So NP will be 200 times zero point 0.5, which will be NP. So 25, 20 into zero point 0.5 will be 100. The variance is NPQ. So it will be 200 into 0.5 into zero point 0.5. So 100 times 0.5 will be 50. So now x follows normal distribution 100 and 50. And we want to find x is greater than 110. Okay. So this will be equal to probability. Again, we will do this x minus mu by sigma. So it will be z. 110 minus 100 will be 10 divided by root 50. And then this value will be z greater than 10 by root 50 is root 2, which is equal to 1 point. So 1.414 will be 0.9207. So now it will be 1 minus 0.9207. So 1 minus 0.07 will be equal to 0.0793. 0793. So let's write this. So these are all questions we can solve this now, I think. So you have 1 minus probability of x is in between 30 to 50. So now probability 30 to 50. 1 minus probability 30 minus this one is what? 47.73 divided by 6.19 as then z less than this one was 50. So 50 minus 47.73 divided by 6.19. So this is 1 minus probability. This one is 30 minus 47.73 divided by 6.19, which is minus 2.86. This is 0.366. So this one will be 1 minus 5 of 0.366 minus 1 plus 5 of 2.86. So this will be 112. 2 minus 5 of 336 and 2.86. So 336, 3, 3. Okay, so it is 0.6293. 0.6293 plus 2.86. So 26 is here, 8 is here, 0.9979, 0.6272. So this is 2, and if you sum these probability, it is 1.6272. So it will be 0.62. No, sorry, this will be minus 2. So 2 minus 627 will be 0.37. So it is 0.37 or 0.35, जो भी, whatsoever is nearby. So it is 0.35. So this is the solution. Okay, so this is everything regarding today's class. If you have any doubts regarding this class or previous or the assignments whatsoever, you can ask now.